So if you understand what I did, repeat it here. This is the real question. But here I selected 4. And as you can see, it's very difficult to calculate all the outcomes. Just use the rule. Do you remember the rule? Read the question carefully.
So,
Yes.
first one and the second one we multiply.
Yes. Okay, we selected 4 calculators from how many? 14 defective and how many? 28 not defective, good ones, which is D bar, right? Not defective. So that means the total is how many? 42. So that's the total. So that we're selecting 4. What is the probability that you get at least 1 defective? Find the probability of at least 1 defective. Again, at least 1 means minimum 1, means 1 or 2 or 3 or 4. That's so many possibilities. And to calculate any one of them will take time. If you get the probability of 1, that's many outcomes will give you this. It could be the first, second, third, fourth. So many complicated. So very complicated. You have a tree diagram, 4 stages. Imagine you do 3. It's very complicated. So we're not going to do that. We're going to use the rule. What is the rule? Who remember? 1 minus the probability of all of them are not defective. Yes. All of them, how many? All of like what? 2, 3, 4, 5? Who's all? No.
42?
No.
It's 48.
Huh?
No, 28.
Oh my God. At least 1 defective from what? From how many we selected? No. We selected just 4. Selected. How do you write select? Selected 4. I'm saying at least 1 from the 4. So the all here means what? All of the 4. Yeah, all of the 4 to be good, not defective. Yeah, so multiply all of them, all of the 4. So that means the first one not defective, the second one not defective, the third one not defective, and the fourth one not defective. And of course we had the option of defective, but we're not going to look at that because we want D bar, D bar, D bar, D bar. So the first one will be not defective is how much? What's the probability that you get D bar? 28 over 42. And second one, 27 over 41, and so on, as you know, 26 over 40, and 25 over 39. And then this outcome here that you're looking for is to multiply. Multiplication rule. Multiply all these numbers. This time, this time, this time, this. And once you multiply them, put the answer here and do 1 minus. Clear now? Clear why we keep reducing? Because to get the outcome at the end, or you keep selecting, you don't put it back, right? Some other questions, you have percentages, like you're selecting from big population and you have certain percentage. Will the percentage change or remain the same? Will remain the same. So maybe your version, when you do this active learning, you will have this kind of questions where you have a percentage, okay, but they will be given this percentage, by the way, and you need the other one, don't forget. Okay, so you have to get the other percentage and make sure you use it in the multiplication without any change. You got lost because I talked too much. I'll give you another example. Forget about what you said. Just solve this one. Look at this one. Tell me if you have any question about this one. Is this one clear? Okay, that's it. That's good enough. I think anything else I say after that, I think you can discover it on your own. So just start your own active learning and see what you will get. There are only 2 questions. Okay, another example. Very similar idea, but this time we're selecting from a big population. which has 65% find a job, and obviously, how many don't find job? If 65 find job, how many don't find job? How many? What percentage don't find? 35. So the tree diagram initially would look like this. I have some of them who find job, some don't find job, J bar. So 65 find the job. That means the probability that you find one of them find job is 0.65. The probability you find it does not have a job is 0.35. And then maybe we continue this way, or maybe continue this way, depending on the question. What the question say? Find the probability at least one find the job. What does the rule say about this? The probability of at least one find job, that means 1 minus the probability all of them don't find job, right? All of them jibal. All of what? All of the people selected. How many selected here? 5 selected. So that means 1 minus the first one does not find job, second one does not find job, all of them. So 0.35, 0.35, 0.35, 5 times multiplied. That's why it's 0.35 power 5. Power 5, so the probability does not change because the percentage does not change. The examples like this, we have a big population. When you select one of them, it really does not change the distribution. So almost remain the same, right?
The difference in percentage doesn't change.
It doesn't change because he didn't give you the total number anyway to subtract 1 from it, right? You don't know the total number. You only know the percentage, and there's nothing you can do about it. So assuming the population is very large, and the percentage will not change. Clear now?